Welcome to this lesson on installing and managing software on Linux systems. In this lesson, you'll learn about the two most commonly used package types and package managers. After completing this lesson, you'll know how to manage software on Red Hat Enterprise Linux, CentOS, Debian, Ubuntu, and other related Linux distributions. Because installing and managing software on a Linux system is a very common task, a standard method of bundling and distributing software was created. Package managers provide a common interface for finding, installing, and uninstalling software. Without packages and package managers, the process is much more hands-on and manual. It leaves things such as hosting the software files up to the developer, and you, as the user, the job of finding that software on the internet. Plus, you'll need to manually download and install the software, potentially compiling it from source code. Once you've completed this lesson, you'll be able to manage software installations on Linux. Specifically, you'll be able to find, install, and remove individual packages, get information about a package and/or determine which package to install given multiple choices, determine if an individual package is installed, list all the packages that are installed on a system, list all the files contained within a package, and find what package a particular file belongs to. Typically, when you install software on a Linux system, you do so with a package. A package is a collection of files that typically make up an application. Additionally, a package contains data about the application, as well as any steps required to successfully install and remove that application. The data or metadata that is contained within a package can include information such as the description of the application, the version of the application, and a list of other packages that it depends on. A package manager is used to install, upgrade, and remove packages. Any additional software that is required for a package to function properly is known as a dependency. The package manager uses a package's metadata to automatically install any dependencies. Package managers keep track of what files belong to what packages are installed, and what versions of those packages are installed. Now that you have an understanding of what packages and package managers are, we can introduce the two types that you will learn how to use in this lesson. Distributions or operating systems such as Red Hat Enterprise Linux, CentOS, AlmaLinux, Oracle Linux, Fedora, Scientific Linux are all RPM-based distributions. RPM stands for Red Hat Package Manager or RPM Package Manager. Debian, Ubuntu, Kali Linux, Linux Mint are all examples of Deb-based distributions or Debian-based distributions. Now here's a little obscure and fun fact. The name Debian is actually the creator's wife's name and his name combined, that being Deborah and Ian, so he called it Debian. Of course, there are other distributions that use these package types, but these are the main ones you will likely encounter at home and in the workplace. By the way, distro is short for distribution. Also, some people call distributions flavors. So just know that a distribution, a distro, and a flavor mean the exact same thing and are often used interchangeably. Now let's take a closer look at installing software on RPM-based distros. Historically, the yum command line utility was the package management program for Linux distributions that use RPM packages. If you are using Red Hat 7 or CentOS 7 and earlier, you will use the yum command. However, yum has been replaced with DNF, starting with Red Hat 8, and we'll cover that in just a minute. If you want to search for a package by its name or description, use yum search string, where string is the thing you are searching for. To display information about a package, use yum info package name. By the way, you can use yum info without supplying a package to get information on all packages your package manager knows about. But be careful because there are a lot of packages installed on a Linux system by default. You can also use wildcards. For example, you can run yum info bash asterisk to retrieve info on packages starting with the letters BASH. It's important that you put the search term that contains a wildcard in quotation marks. If you fail to do that, then the shell will expand the wildcard based on files in your present working directory, and then it will pass that list of files to yum instead of the wildcard itself. Now, this might be a little confusing at this point, but I'll give you a demonstration of how this works in just a minute, and it will make much more sense then. For now, just be sure to use quotation marks around search terms that contain wildcards. Okay, let's get back to what we can do with yum. To install a package, use yum, install, and the package name. You can use the -y option to automatically answer yes to yum's questions. By the way, when you see something in brackets, it means it's optional. So the notation you see here on your screen means you can run yum install package or optionally yum install -y package. Remember, in order to install or remove a package, you need to use root or super user privileges. To remove or uninstall a package, use yum remove followed by the package name. To update all the installed packages on the system, run yum upgrade. If you only want to update one package to the latest available version, supply the package name after the command. For example, you could run yum upgrade bash to ensure you have the most up-to-date version of bash on your system. DNF has become the default package management command starting with RedHat 8 and CentOS 8 and later. DNF is a drop-in replacement for yum. This means that any subcommand you are accustomed to using with yum will work the same way with DNF. For example, DNF search works exactly the same as yum search. As a matter of fact, you can even continue using the yum command on RedHat and CentOS 8 because yum is a symlink or a pointer to the new DNF command. So when you run yum on RedHat 8, you're actually running DNF. If you are using RedHat 8, I suggest that you use the DNF command instead of yum. I highly suspect future releases will remove the ability to use the yum command altogether. In addition to the DNF command, you can use the RPM command to interact with packages. When you use this lower level command, be aware that you do not get all the features of DNF, such as automatic installation of dependencies. If you want to see all the installed packages on a system, you can run RPM -QA. If you want to know which package that a file belongs to, you can run RPM -QF and then the path to that particular file. Use the command RPM -QL the package name to list all the files that belong to that package. If you want to install a package from a file named package.rpm, well, you would use RPM -IVH package.rpm. Use RPM-E followed by a package name to uninstall that package. Now remember, in these command examples that you see here on the slides, the word package represents the package name. Some examples of package names could include Nginx or curl or bash. This demonstration that I'm about to perform assumes that your machine has an internet connection. I'm also using CentOS for this example, but this will work with Red Hat Enterprise Linux, AlmaLinux, Rocky Linux, Oracle Linux, and so on. So again, this is for DNF and RPM-based distributions. Now, as I mentioned, this particular Linux system has an internet connection, and by default, package managers download packages from the internet. On a side note, package managers can be configured to pull packages from a location on a local network. This is useful on a corporate network where you have internal or private software that should only be distributed to company systems. Okay, so let's say we want to install the Nginx web server. So the first thing we would do would be to search for a package named Nginx. Linux keeps a local copy of all the packages that are available in the remote repositories. Now, if that list of packages is old or outdated, DNF will first go ahead and download an updated list of those packages, and that's exactly what happened here at the very beginning of this command. Here, the DNF search command returns a list of possible packages whose name or description contains the search string of Nginx that we supplied to DNF search. Now, one thing I want to point out here is after the period. So you see period.x86_64 or .period no arc or no architecture. So these are the architectures supported by these packages. This means that this package is specifically for an x86-64 processor. This means that this is not specific to any CPU type or CPU architecture. Now, out of this list of packages, I highly suspect that the first one returned, Nginx, will be what we need to install. But let's go ahead and query it to get some more information about it. So we'll use dnf, info, and the package name. Here we can see the version, description, and other supporting information about this package. Now to install it, we need to go ahead and switch to the root user, as installing packages requires root or super user privileges. Let's use the dnf install command to install the package. I'm going to use the -y option to automatically answer yes to any of dnf's questions. And I'll supply the package name of Nginx. So you'll notice here that not only did the Nginx package get installed, but many other supporting packages were too. So in this example, you just saw dependency management at work, and this is one of the key benefits of using a package manager. We can prove Nginx was installed by using the dnf list installed command. We can also use the which command to search for the binary file's path. Let's say we no longer need Nginx and decide to uninstall it. So we'll use dnf remove, and we'll also use the -y option again to skip the confirmation of removal. Remember, removing software requires privilege escalation, either with sudo or su. Because we are already root from the installation step, we don't have to precede the command with sudo, for example. So again, to remove the package, we'll run dnf remove -y and the package name of Nginx. If you want to make sure that your system has all of the latest packages installed with all the latest bug fixes and security updates, run dnf upgrade. If there are any outdated packages, dnf will provide a list of them to you as you see here on your screen. If you want to update them, then type Y and hit enter. By the way, you can also use the -y option here too. So if you want to force an update without reviewing the packages first, you could have run dnf upgrade -y. If all of the installed packages are at the latest available versions, then dnf will report that there is nothing for it to do. Again, here you see that there are several packages that are outdated on this particular system, so I've typed Y and now I'm going to hit enter. And this will tell dnf to upgrade those packages to the latest version. So let's do that now. I'll go ahead and speed up the video here so you don't have to wait the several minutes that it's going to take for this actual upgrade to complete. Now let's take a look at the RPM command, and we can find a package from the internet, download it, and then install it using RPM. Now keep in mind, when searching for RPM packages on the internet, know that your machine's distribution and process architecture matters. Make sure that the RPM package is for your system's particular distribution of Linux. Now sometimes the same RPM can be used on multiple distros, but other times there is a different RPM for each supported distro. Unless the RPM package that you are working with is labeled as no arch, meaning there is no specific processor requirement, you'll need to select the correct option for your processor. If you're using a 64-bit Intel or AMD processor, you'll look for x86_64 packages. If you're using a 64-bit ARM processor, for example, you'll look for AARCH64 packages. You can use the uname command to help determine your architecture. So you use uname space -m, and this will print out the machine's architecture. So here I'm using an Intel CPU, so I have x86_64. So what I'm going to do right now is download a package from the internet to my local Linux system by using the curl command. Curl is mainly used to transfer data over a network, such as downloading a file. The -O option causes the file to be saved locally with the same name that was used on the remote system. This particular RPM package contains the word no arc. That means it will work no matter what CPU type I have, be it Intel, ARM, or something else. So now let's go ahead and install it with the RPM command. So we'll use RPM space -I v h and the name of the file. So I'll type example 1, and I'm just going to hit tab here to let bash autocomplete that for me. So let me hit enter. So now we see that there is a missing dependency of example-lib. So now I'm going to go ahead and download and install that missing dependency manually. After I have the dependency installed, then I can go ahead and install this original RPM that I wanted to install. Okay, I'll install it with RPM. Now I'll go ahead and install that original package from a couple commands ago. So I'm just going to up arrow a couple of times here, and there's the package that I want to install. I'll hit enter. By the way, if these packages were in a repository and we used the DNF command to install the example package, DNF would have also downloaded and installed the example-lib package. Dependency management is a nice feature of DNF. Just know that if you are not using DNF, you will have to perform any dependency management yourself, just as you saw me do here. Also, I quickly want to state that if the packages do not install, that could mean you have made a typing mistake when downloading the package. If you do make a typing mistake, then you'll end up with a file that contains an HTML error message instead of the package itself. So if you run into this issue, just double check your typing and try again. One way to see if the package is installed is to list all the installed packages on the system, and you can do that with RPM-QA. The -Q option tells RPM that we're performing a query, and the A option tells RPM to return a list of all of the installed packages. So when I do that, you see all these packages spew to the screen, scrolling by very quickly. A better way to find the package we just installed is by specifying it instead of scrolling through this long list and looking for it manually. So we'll do RPM-Q example. Because we are specifying a single package, we can leave out the A option because, again, A stands for all. However, we don't have to. This works as well. We'll do RPM-QA and limit it to example. If we want to list all the files included in a package, we can use the RPM-QL command. This package only contains one file named example, and it's located in the user local bin directory. We can double check that user local bin example actually belongs to the RPM that we just installed by using the RPM-QF command. What is returned is the package name that the file belongs to. Finally, let's remove the RPMs that we installed. We'll uninstall the packages in the reverse order that we installed them. If we don't do that, RPM will print an error telling us that another package depends on the one that we are trying to uninstall. Also keep in mind that we don't have to specify the architecture or file extension for the package. We can just use the package's name. So I've just uninstalled example. Now I've uninstalled the example-lib package. And to be totally certain we uninstalled the package, we can repeat the command from earlier to search for an installed package. As you can see, it says the package example is not installed. By the way, if you get nothing returned as well, that also means that the package was uninstalled. Now, if you remember way back earlier in this lesson, I mentioned that you could use wildcards, and I also told you to put wildcards in quotation marks. Let me demonstrate why now. So let's get some information on packages that contain the text example. The asterisk matches any character or an empty string. So asterisk example asterisk means that the package name can have any characters before or after example. So a package named example123 will match asterisk example asterisk, and a package named my-examples will also match. So let me hit enter here. On the screen here, you see a package named qt5-qt xml patterns-examples. And of course, that package matches the wildcard pattern. However, look at what happens if we don't enclose the wildcard search in quotation marks. Now we get a message that says no matching packages to list. The reason is because example was expanded first, and then that expanded content was passed to the DNF command. Now we can demonstrate this expansion with the ls command. So I'll do ls example asterisk. So I'm actually going to highlight this text here and copy it. So running dnf info example is the exact same command as running what you see here on your screen. So again, the important thing here to remember is that if you are going to use wildcards, just use quotation marks.